Okay, we're going to start our third lesson today, and our third lesson is about something called a production possibilities frontier. All right, and to understand all of what that very complicated thing means, and by the way, we're often going to refer to production possibility frontiers as PPFs for obvious reasons. It's just kind of a pain to write all that out all the time. But a production possibilities frontier is essentially going to kind of put in a picture form everything we've been talking about for our first two lessons. So let's take a look at what we've been talking about kind of as a review first. What have we learned so far? Well, the first thing we've learned is that economists study how people make decisions. We know that from our very first lesson. Why do they make decisions? They make decisions because resources are scarce and human needs and wants are unlimited. So we don't have enough things. We want everything, so we have to make choices. And when we make choices, we have that wonderful thing called opportunity cost. We have to give up other things. And again, the study of economics is, why do we make the decisions that we do? Given that we have scarce resources, why do we choose certain opportunity costs over others? We haven't so far we've talked about that kind of conceptually so far, but we haven't put it into a form that economists love, which is a picture form or a model form, or in this case, we're actually going to talk about a graph form. Second, we also learned in yesterday's lesson that because resources are scarce and because we have opportunity cost, we have to ask questions. And different societies, as we learned yesterday, answer those questions differently. What were those questions? For whom do we produce? What do we produce, and how much do we produce? Now, we can think about that conceptually, or we could put it in the form of a model. And the most common kind of model that we use in economics is what's called a graph. Now, I'm sure many of you have had experience with graphing so far, and the truth is, if you haven't, you're going to have a lot of experience with graphing this semester. This is going to be today's lesson, the production possibilities frontier, our very first graph. And we will do many, many, many graphs throughout the semester. Before we do that, I want to begin with a quick review of what a graph actually looks like, all the pieces and parts. The first thing we should remember is that a graph has two axes. The horizontal axis we call the x-axis, and the vertical axis we call the y-axis. What a graph does, in particular in this case a line graph, which is the one we most commonly use in economics, it takes two variables, one on the x-axis and one on the y-axis, and creates a relationship between the two, or shows a relationship between the two. In this case, this graph happens to show that x and y, or excuse me, whatever is on the y-axis has a negative relationship with whatever is on the x-axis. In other words, as whatever is on the y-axis goes down or decreases, whatever is on the x-axis increases. Now, that line that shows us that has a name. It's called a curve. Now, that happens to be a straight curve, so you might be wondering why we call it a curve. Well, it's still a curve. The actual line that shows the illustration we call a curve. All right, that's some very basics of graphing. And again, what we're showing here is that in this instance, when there is 1,000 of whatever is on the y-axis, there will be 1,200 of whatever is on the x-axis. It shows a relationship between two things very easily and very clearly. By the way, one other point I want to make is the point where we essentially end up with zeros for both the x-axis and the y-axis. This point right down here in the corner, there, we call that the origin. Just a point that I thought was worth making. Okay, let's get into our first graph, the production possibilities frontier. Now, what is it, first of all? It's a graph that illustrates various combinations of output that can occur given a certain amount of resources. Now, that sounds pretty complicated, but okay, now that we feel comfortable with looking at a graph, I want to begin by drawing our very first production possibilities frontier, or PPF. And we're going to do it about an imaginary place called Motorville. Now, Motorville can only produce two goods, tractors or cars. Now, by the way, I realize that most towns can probably produce more than two things, but with like most good models, especially for beginning students, we're going to keep this very simple. Two products is all that Motorville can produce. And what would be the thing that's keeping Motorville from producing more? Well, it's how many resources do they have? How much, in this case, maybe it's, I don't know, scrap metal, and how much motor oil, and how much whatever it is they need to produce tractors and cars. They only have a certain amount, and therefore they have to make choices about what they produce. So let's start with this. This right here is what's called the production possibilities frontier. Let's take that whole term and see why, what that actually means for this line. A frontier. Well, what is a frontier? Sometimes I think of Star Trek when I think of frontiers, the last frontier, right? Well, frontier is the very outer edge, the very limit of something. We used to call the West, before we knew anything about the West, we used to call it the frontier because it was as far as people could safely go before they went into the unknown. All right, so a frontier is sort of an outer boundary. Think of this line as an outer boundary. It's the outer edge of what's possible to produce. Okay? So what we're really saying is this line represents the number of tractors and cars that Motorville can make if they use their resources perfectly. In other words, it's the absolute max that they can make if they use their resources perfectly. Or in economics, we'd like to say, use them efficiently. So let's take a couple examples and explain what I mean. So what are we saying so far? Actually, back up for 1 second. What we're saying so far is that a good use of resources would be to either produce 3,000 tractors and 0 cars, or 1,000 cars and 0 tractors. Now, why is one good or better? I don't want to say good. What I want to say is if we're using our resources well, in other words, nothing's being wasted, this PPF tells us that we can either produce 3,000 tractors and no cars, or 1,000 cars and no tractors. But there's lots of points in between. Like, for example, it's also true because we're on the PPF, right here, that we can produce 2,000 tractors or 700 cars. And in that case, we're still using our resources as much as we possibly can. We'll call that point A. It's also possible that we could produce 2,200 tractors and 600 cars. And that also is a good use of our resources. We're using our resources efficiently. Now, where exactly a country decides to produce on the PPF, that's a decision that has to be made because of those 3 questions. And every society has to ask those questions. Well, what do we really need more? Do we need more tractors? Do we need more cars? What's going to sell better? Those are all questions that every nation's going to have to make a decision about. But what we know for sure is that if a nation decides to produce, in this case, let's say 2,200 tractors, they must produce 600 cars in order to not waste any of their resources. That's what the PPF tells us. Now, suppose they tried to produce at point D. Point D is outside the PPF. If I'm rounding off, it looks like maybe it's 3,000 tractors and maybe about 700 cars. The truth is, right now, Motorville can't produce point D. Why? Because it's beyond the PPF. No matter how much they try, they don't have the resources to produce 3,000 tractors and 700 cars. They just don't. By the same token, suppose they decided to produce only 1,000 tractors, suppose they decided to produce 1,000 tractors and then only produce 300 cars. According to our PPF, that's what we would call an inefficient use of resources. Why? Because if we're producing 1,000 tractors right here, according to our PPF, we should be way over here somewhere producing, I don't know, maybe 900 cars. Since we're only producing 300, that means that we are using our resources inefficiently. The goal is to end up somewhere on the PPF. If we're on the PPF, then we're using our resources well. Anywhere inside the PPF is a sign that we are not using our resources well, or we're using them inefficiently. Okay, I want to spend one more moment here talking about opportunity cost. We know that, as always, the issue is we have scarce resources, so we have to make decisions. Well, in this case, we're illustrating opportunity cost. Well, how do we do that in terms of actual numbers? Well, take a look at this example. Suppose that we want to produce 2,000 tractors. Well, if we're doing everything well, how many cars can we produce? Hopefully you said 700 cars. Fine. But suppose for whatever reason we decide we want to produce more tractors. Instead, we want to produce 2,200 tractors. Well, in that case, how many cars can we produce? Hopefully you said that now we can only produce 600. So, what is the opportunity cost of producing 200 additional tractors if we were producing 2,000 and now we're going to produce 2,200? The answer is 100 cars, or 600 instead of 700. And that's really it. Let's try doing some examples. Okay, take a look here at our example. What I'd like you to do is I'm going to pose these questions here. I'm going to ask you to pause for just a minute, the video, and answer these questions. And then I'll provide the answers for you when you're ready to start again. Okay, hopefully you're ready to go. Let's take a look at each of our questions. The first question, what is the opportunity cost of increasing production from 400 to 500 cars? Well, if I was producing 400 cars, I could at the time make it looks like 1,300 tractors. But if I want to increase my car production, remember my resources are limited, I want to make 100 more cars, then I can only now produce 100 tractors, which means, 1,000 tractors. I was producing 1,300 tractors, and so my opportunity cost is 300 tractors. Number two, which point represents an efficient use of resources, or points? Actually, in this case, 2 points do, both W and X, because they are both on the PPF, so the answer is W and X. Which point represents a production level that is impossible? Well, right now, that would be point Z. That's outside our PPF. We have no way to produce those goods right now. We just don't have enough resources to do that. And lastly, which point represents an inefficient use of resources? That would be point Y. Any point that's inside the PPF means that we're not using all of our resources well. Good. Okay, we're back to our friends here in Motorville. Let's take a look at their PPF one more time. Right now, as we learned a minute ago, we learned that any point on their PPF is a point that shows they're using all of their resources well. So in this case, for example, point A, 2,000 tractors, 700 cars. That means everything that they can have, all of their labor, all of their capital, all of their natural resources are being used as best as they can to produce 2,000 tractors and 700 cars. We also learned that point E right now is impossible. It's outside the PPF. Is there a way in which we could get to point E? Well, the answer is, of course. Countries do it all the time. They expand their ability to produce, or actually in economics we use the term, they grow their ability to produce. Well, how would that happen? Right now, as we said, they can't make that combination. 2,100 tractors and 750 cars are currently beyond their PPF. What we really need is their PPF to go that way. How would it do that? How would I bump my PPF out? Well, the answer, which I put up a little too soon, but there it is more resources. Let's suppose the thing that was holding them back originally was they didn't have enough sheet metal. But then they went and they did some mining and they got some more sheet metal. Now watch what happens. The PPF shifts outwards. And now point E is an efficient use of resources. They can produce 2,100 tractors and 750 cars. The key to moving the production possibilities frontier out is more resources. So it might be something as simple as finding more natural resources. It could be adding more capital. For example, discovering a technology that would allow them to produce tractors and cars with less people or with less natural resources. Anytime you add more resources, you increase the production possibilities frontier for a country. Okay, Very quickly, we want to finish up by talking about the different shapes of a PPF. This is kind of a bonus, but it's worth mentioning. All right, so we have a country here that can produce guns or butter. And by the way, I mentioned that one because that's a very common example economists like to use because they really represent two completely different things, right? Butter and guns. But that's not that important for right now. Okay, so what does a curved PPF look like? Well, obviously you can see the shape, but really what it means is this. It means that as you move toward the ends, as you move toward producing all of one good or all of another, it seems to be that you give up more and more of the other good. So I'll show you what I mean by this. Suppose right now that I was producing 1,200 butter and 1,200 guns. Well, if I decide that I want 800 more butter to get to 2,000, I have to give up 1,200 guns. In other words, as I move toward the end, I had to give up a lot more guns to get not as much butter. The difference is also this kind, is in contrast to this kind of PPF, or what we call a straight PPF. If you have 1,200 pounds of ham and 1,200 pounds of bacon, if I gave up 1,200 pounds of bacon to get to 0 bacon, I would gain 1,200 pounds of ham. In other words, I seem to have given up just as much bacon to get just as much ham in the process. So what's the difference between the two and why are they shaped differently? So what's the reason for this? Why do some PPFs have that curved shape and others have a straight shape? Because of the note I have there on the bottom. The more constant the PPF slope, the more well-suited the resources are for producing both goods. Take a look at the one on the right. We're producing ham and bacon. Well, not too surprisingly, the resources there, we can imagine they're probably pigs, are good at producing both bacon and ham. So, if I decide to give up 1,200 pounds of bacon, or to move from 1,200 to 0 pounds of bacon, I'm going to gain just as much ham back. 1,200 pounds of ham and move all the way up to 2,400 pounds of ham. Equal what I gave up is equal to what I got back. Again, because the pigs, they don't care. They can either make bacon or ham. They move very easily both ways. The one on the left, however, the curved PPF, that's not necessarily true. We can probably imagine that butter and guns require very, very different resources. So, when we're at 1,200 butter and 1,200 guns, we imagine that all the people, let's say, that are good at making guns are making guns, and all the people that are good at making butter are making butter. But let's suppose we decide to give up those 1,200 guns and go down to 0 guns. How many butter do we gain? We only gain 800, moving from 1,200 to 2,000. Why is that? Well, the reason is probably because when we forced everyone to make butter, it meant that some of the people who were good at making guns now had no choice but to make butter. And quite honestly, they probably weren't as good at it. And so they weren't able to produce as much butter as they were guns. Now, that's not to say that's a bad decision. Maybe the country really needs 2,000 pounds of butter and doesn't need any guns. We don't know. But what we do know is that they did give up more. Their opportunity cost was more in a curved PPF because their resources didn't go back and forth as easily.